Okay, so the first graph we're going to draw is the graph of y equals 3 to the power of x. We need to figure out where it's going to intersect the y-axis. So where it intersects the y-axis, we know that the x-coordinate is 0. Now 3 to the power of 0 is equal to 1, which implies that the y-intercept is 1. And if we look at all of the graphs we're going to draw, you can see that this is actually true for every single one of these curves. Each one is going to have a y-intercept of 1. Now, y equals 3 to the power of x, and our values are going to get bigger and bigger and bigger and bigger. Our y values are going to get bigger as our x values are going to get bigger. So that is the line y equals 3 to the power of x, and we've got our y-intercept of 1. Now we're going to draw y equals 2 to the power of x. Now if we compare the values for y equals 2 to the power of x to y equals 3 to the power of x, now 2 is smaller than 3, so 2 to the power of 2 would be smaller than 3 to the power of 2. And in fact, if x is the same, the values for y equals 2 to the power of x are always going to be smaller than the values for y equals 3 to the power of x. Is going to look like that. So for all of our positive values of x, y equals 2 to the power of x is smaller than y equals 3 to the power of x. For example, y equals 2 to the power of 2 is 4, y equals 3 to the power of 2 is 9. So 4 is smaller than 9. However, when we look at our negative x values, we're going to get greater values for y equals 2 to the power of x. For example, y equals 2 to the power of minus 2 is equal to 1 over 2 squared, which is 4, and y equals 3 to the power of minus 2 is equal to 1 over 3 squared, 1 over 9. So when we get to negative x values, the y values for y equals 3 to the power of x are smaller than y equals 2 to the power of x. Now when we look at y equals 1.5 to the power of x, we get something like this. So now, y equals 1.5 to the power of x, when the x values are positive, this is smaller than the other two curves. However, when the x values are negative and we get that reciprocal, the fractions are going to be bigger, so our values are going to be bigger. We're now going to draw y equals 2 to the power of x and y equals a half to the power of x. Now if we actually look at the relationship between these two curves, y equals 2 to the power of x is actually a reflection in the y-axis of y equals a half to the power of x. This is because a half is equal to 2 to the power of minus 1. So a half to the power of x is equal to 2 to the power of minus 1 to the power of x. Using your laws of indices, that's 2 to the power of minus x. So if f of x is equal to 2 to the power of x, f of minus x is equal to 2 to the power of negative x, which is a half to the power of x. That is a reflection in the y-axis. If the negative sign was outside of the function, it would be a reflection in the x-axis. So we're going to start off by drawing y equals 2 to the power of x. We've already drawn this in our previous example, so that looks something like that. where our y-intercept is 1. So we know that y equals a half to the power of x. Could have really extended my axes to properly show that that is a reflection in the y-axis, but it's as if we're putting a mirror here. So we're going to have something looking like that, where it would be a mirror image if we had a mirror going down the y-axis. So that's y equals a half to the power of x. We're now going to look at drawing y equals a half to the power of x subtract 3. So if we say that f of x is equal to a half to the power of x, we are going to draw f of x minus 3. So that's a half to the power of x minus 3. We know that this is a translation by the vector (3, 0). So when we've got the number inside the bracket, we're taking the opposite sign, moving right or left. So it's going to have the exact same form as y equals half to the power of x, but it's going to be translated 3 to the right. Our y-intercept that was originally 1 is going to change, and we need to find out the exact value of that y-intercept. So we know that the y-intercept is when x equals 0, so we're going to find f of 0 minus 3, which is a half 0 minus 3, which is a half to the power of minus 3. So we've got a fraction to the power of a negative number, so we're going to do the reciprocal to the power of 3, which is just going to be 2 to the power of 3, which is 8. So we know that our y-intercept is going to be at 8, and it's going to have the same form as our previous example. So it's going to look something like this.